Hello. Hi everyone. Thanks for joining. Can you hear me? Can you confirm if you can hear me well? Hello. Hi everyone. Thanks for joining. I'm just waiting for some more folks to join, then we will start. I was a couple of minutes late due to network problem. Maybe some more people are joining in the background. Hi everyone. Thanks for joining. Can you please confirm if you can hear me and if you can see my screen? And please press like so that I know I'm audible and I'm visible and everything is good. Could you please drop a message and press the like button if I'm visible, audible, and things are looking fine? Okay, so in the interest of time, I will get started and you can just drop a message if you face any issues or if you are able to hear. So the theme today is SVM for the quiz and it will be very normal theme that we have normally. So there will be a question on the screen and then we will decide what is the right answer and we will discuss a bit on that. Today we are having 15 questions and the reason I have put 15 questions is towards the end I want to discuss some interview specific questions. I have felt that those are not answered well by people. So I'll tell you how to answer if you encounter those type of questions. So I have kept 5 questions for that I will talk towards end. But now we will see 15 questions from SBM topic. So whatever you feel the right answer, you have to drop in the comment. Fine. Let's go ahead and see the first one. In SVM, the margin refers to, and you can read the options. If my video goes off, don't worry. I'm doing something parallelly, but I'm here. Okay, so you can read the answers and you can uh, respond in the chat. So I'm getting 2 3 answers with option B. So people are saying the distance between the decision boundary and the nearest data points. Let's see what is the right answer for this. And I feel whatever people have said is the right answer. So basically the right answer here is the distance between the decision boundary and the nearest data point. And explanation is very simple. The margin in SVM is the distance between the decision boundary hyperplane basically in SVM whenever the classification happens, right? So there is a decision boundary created that you call as a hyperplane, and the closest data point on both sides, if we talk of a two class scenario, right? Closest data point on both sides, those are called support vectors. So SVM tries to maximize this margin, right? That is how it works. Let's go to the next one. You can read the question and try to answer in the comment. What is hard margin in SVM? I don't see any comments. You can just give 2 slash what do you think is the right answer. So for example, if you feel C is the right answer, you can say 2 hyphen C so that I know you are answering question number 2. Which of the following is true about hard margin SVM? What do you think? What is hard margin and what is soft margin basically? Okay, let's see the answer. It requires data to be linearly separable. Why? Because the difference of hard margin and the basic difference between hard margin and soft margin is hard margin will not allow the misclassifications, right? So if your data is not separable, then hard margin is not going to work. So if you are wanting to use the hard margin SVM, right? Then what should happen is your data should be linearly separable. Then your hard margin classifier will work good. The reason we are asking and we are discussing these things is, as I keep telling, right, you will not get time to read these. You might be working on one kind of use case, not getting time to revise other kinds of concepts. But if you go to interview, they'll not hear all these things, right? They want you to know at least fundamentals, conceptual things on all the machine learning algorithms, right? That is the reason we are bringing new topics every week. So here we are discussing hard margin. Hard margin, what it tells you is, hard margin tells you, I do not want any misclassification. So if your data is not separable, right, misclassification will happen. So we are saying which of the following is true. It requires data to be linearly separable. So B in this case. Let's see the next one. What is the purpose of slack variable in soft margin SVM? Not seeing any answers for 3. You can say 3 hyphen, whatever you feel. 3 hyphen A or B or C or D, whatever you think is right. Okay, somebody saying 3 hyphen A. Have you heard of slack variable in SVM? What is basically slack variable? Okay, let's see the answer of this. So it allows some data points to be misclassified. So if you see here, it talks about slack variable in a soft margin SVM. So just now we discussed about soft margin and hard margin, right? So slack variable, what it does in the context of soft margin is, slack variable allows some data points on the wrong side of the margin enable better performance on noisy or non-linearly separable data. So how do you allow the misclassification? Through the slack variable. In the context of SVM, what does kernel trick refer to? Now, this is an important one and conceptual one again. So what do you think is kernel trick in SVM? A method to scale the data, a way to transform data into higher dimensional space, a technique to remove outliers from data, or a method to handle missing value. What is kernel trick do? So some people are saying 4B. Is it a way to transform data into higher dimensional space? Do you agree? For question 4, what is your answer? In context of SBM, what is kernel trick? Let's see the answer here. It is basically a way to transform data into a higher dimensional space. Okay. So the kernel trick allows SVM to operate in a higher dimensional feature space without explicitly computing the transformation, making it possible to classify data that is not linearly separable. So this is important here. What kernel trick does is it allows SVM to operate in a higher dimensional space without explicitly computing the transformation. It does not compute the transformation explicitly. Okay, it allows just higher dimensional feature space, and that is the magic of kernel trick in SVM. So B is correct for 4. Let's see the next one. Which kernel function is most appropriate for classifying data with complex decision boundaries in an SVM? So linear kernel, polynomial kernel, sigmoid kernel, radial basis kernel. You would have heard about these kernels. Which of this kernel do you think is appropriate for classifying data with complex decision boundaries, where decision boundaries are complex? Which one do you think will work better? Some people are saying polynomial kernel. Any reason for that? Some people are saying radial basis kernel. Any reason for that? Can you just tell me why do you think it's polynomial and why do you think it's radial basis? Whoever is telling those answers. Why polynomial and why radial basis? Can you just tell me? Puspendra and Sabikun both are saying option D, that is RBF. Just and Ashok Sai is saying option B, that is polynomial. Why do you think so? I'm getting one answer for RBF kernel. Saying RBF is particularly effective in complex decision boundaries. It can have higher dimensional data and non-linear relationship. Yes, I agree. But people's argument could be in polynomial as well. Yes, the right answer for this is RBF only. Okay. And RBF kernel is widely used in SVM for its ability, as you guys are saying, right? So RBF is more preferred in complex scenario as compared to polynomial, and the reason for that is it can handle non-linear decision boundaries very well. Okay, so that is the recommended kernel to be used, RBF. Let's go to the next one. In SVM, the C parameter controls what? Have you heard of C parameter in SVM? And what it controls, do you know? So you can tell 6 hyphen your answer, whatever is your answer. D, number of support vectors. No, I don't think so. The parameter C is basically for your regularization strength. So C parameter is something you can read about this later, but C parameter controls the trade-off between it's a kind of concept in when do you want to create the decision boundaries. Okay, so it's a trade-off between maximizing the margin and minimizing the classification error. A smaller C, if you put C small, right, allows for wider margin with some misclassification, while larger C focuses on classifying all points correctly. So if you go to SQL and the SVM page, right, it's very simple to understand, and this is not a complicated thing to understand. Just likely a hyperparameter that you can tune. In SVM model, we have just seen C with a large value of C. The classifier, what will happen if the value is large? So if you go to previous question, right, we discussed what C does. Now what will happen if C is large? So if I go here, right, from here we can, a smaller C allows for a wider margin, while larger C focuses on classifying all points correctly. So if you have too large C, then what will happen? It will overfit, underfit, or something to do with support vector or margin width. Okay, so uh, since a larger value of C tries to correctly classify all the items, what we are trying to do is we are trying to get a model with great accuracy. And whenever we try to do that, typically what we tend to do is we tend to create a overfitted model. So same scenario here. If you try to have a model which does not make any mistake, normally what you will end up doing is overfitting, right? So overfitting is what is the right answer here. A larger C value penalizes misclassification more heavily, which forces the model to classify as many points correctly as possible, potentially leading to overfitting. Okay, so that is overfitting. Which of the following is true about the support vectors in SVM? Support vectors are always correctly classified. Support vectors are the point closest to decision boundaries. All data points are support vectors. The number of support vectors is always fixed. This should be a easy one. You can say 8 hyphen ABCD, whatever. Okay, I think some people are saying B, point closest to the decision boundary. We will see that. Are there any other opinions on this? Any other thoughts on this? B. Okay, so most of the people agree with this on B. Support vectors are nothing but data points that lie closest to the decision boundaries. These points are crucial in determining the position and orientation of decision hyperplane. So whenever margin is created, whenever the plane is created, the boundary is created, right? On both the sides, or if you are talking a multi-class scenario, right? On every side, whatever is the closest to that boundary, that is your support vector. Which of the following properties makes SVM a robust classifier? Which of the following properties make SVM a robust classifier? What do you think? If I have to ask this in a different way, right? What do you think is make how SVM is better than rest of the model? It can handle missing values efficiently. No, missing values can be handled by other models better than SVM. What else? I'm saying I'm getting answers 9C. It maximizes the margin between classes. Any other opinions? I'm getting 9C from multiple people, and that's correct. So you have to think like, when do we say a model is robust? SVM is robust because it maximizes the margin. So what it tries to do is it tries to create the maximum difference between the behavior of this class and this class. That is the intention of SVM. In other models, what we are trying to do, we are trying to learn in a different way. In SVM, what we are trying to do, we are trying to see how this class is different from this class. That is the only intention with which the model fitting is happening. And that makes SVM special. So it maximizes the margin between the class is the intention, and hence it makes your model more robust. Which of the following is false about the kernel trick in SVM? You can read the options. This is something we have seen before as well. What is that SVM does not do? So if you remember in the kernel trick, we had discussed this. Okay, yeah, I think most of the people are right here. So it computes the transformation of the original data explicitly. Explicitly, it does not compute. I think option C is also which is right. So most of the people are saying option C, but option B is also correct. It computes the transformation of the original data explicitly. Explicitly means, is it doing it? Is it computing the transformation explicitly? Is it doing some kind of PCA, some kind of transformation? No, right? So B and C both correct. If you are saying C, C is also right and B is also right. In my answer, I have taken B. Kernel trick avoids explicit transforming data into higher dimensional by calculating inner product. Okay, I think it is kind of, I have put B, but I have written C here. Okay, not a problem. So basically both of these are related and kind of same. Okay, so explicit computation does not happen is what we need to understand. Which of the following kernel function is not typically used in SVM? Which of the below is not SVM function? Sorry, kernel function. Linear, polynomial, sigmoid, Gaussian, naive. Yeah, this should be clear because all of us know linear, polynomial, and sigmoid are kernels. Gaussian naive is not a kernel. So Gaussian naive kernel does not exist in the context of SVM. Popular SVM kernels include polynomial, sigmoid, and RBF, etc. What does the decision boundary in a SVM correspond to? What do you call decision boundary? The line that separates support vectors from non-support vectors, the hyperplane that separates different classes with maximum margin, the distance between two closest support vectors, or the margin width. What is decision boundary? Okay, so here people are saying in question 12, people are saying B. How many of you think it's B? Or you have any other opinion here? So the answer correct here is B only, the hyperplane that separates different classes. The decision boundary in SVM is basically that hyperplane itself that separates the classes. Okay. In a SVM with a linear kernel, which of the following will happen as the dataset becomes increasingly non-linearly separable? If you are using a linear kernel and if your data is non-linearly separable, then what will happen? Thirteen. What is the answer? 13B. People are saying B. Let's see what is the right answer. So if you are using a linear kernel and your data set itself is not linearly separable, right? The simple thing that will happen is linear SVL will struggle to correctly classify the data points. As simple as that. It will not be able to do. You need to use a different kernel. In a non-linearly separable data set, which SVM techniques allows correct classification? In a non-linearly, so kind of related question from the previous one. If it is a non-linearly separable, right? Then which SVM techniques will allow correct classification, or you can say in one way, a better model? Some people are saying soft margin SVM with an appropriate kernel. Some people are saying hard margin SVM with a polynomial kernel. So my data is non-linearly separable, okay? And I want to have correct classification. By correct classification, I mean to say here the better model. Don't think correct classification means hard margin. Don't think like that. I mean to say a better model, a flexible model here. So you can get a flexible model with soft margins. So soft margin SVM with the appropriate kernel. So here we are not mentioning any kernel also. We do not know. We are just saying non-linearly separable data set. What kind of data we don't know. Okay. We don't know. So we can't say whether linear will work or polynomial will work. So kernel part, we are keeping it open by saying appropriate kernel. And every time we want flexibility in the model, we want to go for soft margin classifiers, soft margin SVMs. So a soft margin kernel such as RBF polynomial allows linearly separable by mapping data into higher dimensional space. So if it is a soft margin and if you use the right kernel, you are going to get a more flexible, more better model. So don't think that correct classification means hard margin. No. In SVM, how is the duality problem solved? I'm not sure if you have heard of what is duality problem, but if you know what is how is duality problem solved? Fifteen. What do you think is the right answer? Try 15. Just try. No need to be right. Just you can try. Okay. Let's see. By solving the dual problem, you can read about this problem. This is a basically a something to do with the how optimization is done in SVM. Okay. And SVM solves the dual problem because it allows kernel trick and can be computationally more efficient, especially in higher dimensional space. Duality problem is to do with how the optimization happens in the mathematical functions. Okay. So you can read about singular problem and duality problem both. So if that happens, right, it allows kernel trick that can be computationally more efficient and it can be solved using that. So this was 15 questions that I had put for today. And what I had decided is I will discuss five questions on based on my recent experiences with some of the data science interviews where people were asked some questions and they are not able to rightly answer that. Okay. But what I see is there is festive weekend and attendance is below 10. I feel let's park it for the next weekend. Okay, I will take those five questions or maybe more than that, and I will explain you. Questions such as how do you stay updated in data science? This is a very open-ended question, right? But if you are not ready for this in the interview, it does not give a very good impression. And there are some more things in my mind. I will park it for the next session next weekend. Please join next weekend, and that is not a festive weekend, so I expect more people to join. And till then, have a lovely rest of the weekend. Have a lovely festive weekend with your friends and families. I'll see you all next Sunday, same time, with a different theme, but my focus will be on the important interview questions. Let's see on the next Sunday. And if you like the video, just you can say thanks, it was good. That gives me a feedback and I can tune my session accordingly next time. And I'll meet you all next Sunday, same time. Thanks everyone for attending and joining.